Hi there, Year 8. So this is exercise 9F. It's on about gradients. Now, this is actually a very, very difficult concept to get overall, but at Year 8 level, you just need to be able to do a couple of calculations. So I'll give you a bit of theory, but not really a lot. I won't go into depth with it. Okay, so here, let's have a look here. You've got every straight line equation can be formed in this equation here. So what you see that I've just boxed around, this is called your general linear equation. And linear just means straight line. Okay, so the word linear means straight line. So it's saying that for every straight line that you want to draw, it will look something like y equals to mx plus c. Now, the two key components that's very important in this equation is m and c, okay? Now, you're just going to fill this in here. M, which is known as the gradient, okay? And c is known as the y-intercept, okay? The thing that you learnt in exercise 9E, so how to find the y-intercept. And hopefully you remembered that the y-intercept, what we know is the x-coordinate is always going to be 0 or has to be 0. So x equals 0 is a must in order for you to have a y-intercept. Okay, so just write those notes down. Now, a couple of things I'm just going to fill in and you're just going to copy down for now, okay? So we're just saying y equals mx plus c. The number, so m is a number. Whatever that number is in front of x, okay, that is the gradient. And then the number that's left by itself is your y-intercept. So here's an example. Say I gave you y equals 2x minus 1. The number in front of x right now, hopefully you can see, is 2. Okay, so m is equal to 2, and that is your gradient. Gradient equals 2, and this negative 1 is your c. So your c, which is your y-intercept, is at negative 1. Okay, that's pretty much, at least for this part here, that's all you need to know. Now, to fill in the blanks over here, what is the gradient? Well, the gradient is how steep a line is. So when you draw a line, okay, so you can draw a line like this, you can draw it like this. You see how I'm making it flatter and flatter? Well, the gradient, depending on what the number is, it dictates how steep the line is. So obviously this is very steep. Okay, steep is kind of like the idea that if you were to climb up this mountain or this hill, this is very hard. The steeper it is, the harder it is. The flatter it is, the easier it is. And that's essentially what the gradient does. So I can quickly show you on Desmos, just to illustrate a point here. So I'm just going to go to Desmos. Let's go to desmos.com. If I typed in y equals, let's make up a line. Let's go 2x plus 1. See how I've got a straight line straight away, and it's m, the gradient is clearly 2. It's the number in front of x, yeah? And then c, which is the number positive 1. So c is the y-intercept, and you can see that it does cross the y-axis at 0, 1. And that's where the y-intercept is. Okay, so when you say c equals 1, see that number there, plus 1? That actually just tells you where the intercept is. So if I change it to plus 2, you'll see that it's now at 2. See, 0, 2. That's where it crosses the y-axis. Okay? All right. Now, let's have a look at m. When I increase m, if I make m really big, okay, so if I changed m, so let's say the number is 3, I want you to see what's happening to the equation, okay? So have a look at what's happening to the equation. When I change it to 4, 5, 6, 7, 8, 99, what's happening to the line? Can you see how it looks really, really close to the y-axis? In fact, I can make it a bit more obvious for you. I'll just call it m, all right? And I'll use the slider over here to make it more obvious. But when I change m, can you see as I increase m, can you see how it's getting steeper and steeper? In fact, I'll just make the maximum up to 100 so we can play around with it. Can you see how the more I increase m, the larger m is, the bigger the number m is. If m is 79, so if I had 79x plus 2, the line is really steep. So in your notes here, I want you to write the larger the number, the steeper it is. And then, obviously, the smaller the number, it's going to be really flat. So the smaller the number, the flatter it is. So here's an example. Let's go back here. So I'm going to change it again. I'm going to say now, let's go 5, 6. So you can see how it's a bit, it's not as steep now. If I go to 5, it's getting a bit flatter. 4, 3, 2, 1. And then watch what happens when I make it half. 0.5, 0.4, 0.3, 0.2, 0.1. See how it's sort of flattening out right now? And if I made it 0.01 or 0.02, 0.01, 0.001, see how I'm making it smaller and smaller? It's now looking flatter and flatter. It's not as steep. See what's happening there? So the number in front of x, m, which we call the gradient, the larger the number, the steeper it is. The smaller the number, the flatter it is. That's all you need to understand, okay? You can play around with Desmos to get the feel of that idea as well. So then you might question, well, what happens when it's negative? Well, when it's negative, it just switches sort of the direction that it goes. So over here, I just want you to copy what types of lines you can draw. So you can draw a positive line, which looks like this. Okay, so a positive line from left to right. So if you drew from left to right, can you see how it's sort of inclining up? It's going up. So from left to right, I'm going up. It's inclining up. Whereas a negative gradient, or negative line, sorry, would look something more like this. It goes down. So from left to right, can you see how it's sort of going down? See that? It's declining. So you'll see it over here. If I change this, if I went back to 3 again, so that's a positive line. See how positive 3, gradient is positive 3. Right now it's a positive 3. Number in front of x is positive 3. So it's a positive gradient. So from left to right, it goes up. But if I just put a negative in front of it, so let's say it's a negative 3, then from left to right, it goes down. Can you see how it's declining? So that's my negative line. So m, the gradient, tells you that it either goes down, so it's a negative gradient, or it is a positive gradient. And you can still have a negative steepness line. So for example, if I had negative 99 or 79, can you see how it's very steep, but it's a negative line. From left to right, it's going down. Okay, so all I did was I just changed the number m. So the number in front of x, if it's negative, it goes down very steeply. So it's more about the negative just flips it, the direction, but the larger the number, the steeper it is, and the smaller the number, the flatter it is. That's all you need to take, okay? Now, what do you write in these 2 square boxes here? You just write here 0, and you write here undefined. I'll talk more about it in the next video, which is exercise 9G. But for now, 9F, you can just copy these notes here. So you got a line that goes up, you got a line that goes down, and then you also have what we call a 0 gradient or type of line, which is when it's horizontal. Okay, so when it's horizontal, we say the gradient is 0, so m is 0. So for example, in this one, if I wanted to have a horizontal line, I'll change the number in front of x, I'll change it to 0. You see it's a nice, perfect horizontal line. Okay, and obviously the reason why it crosses through 2 is because I have the y-intercept at 2. Had I changed it to 1, then it'll be a horizontal line crossing through 1. If I had a 3, then it crosses through 3. Okay, so the gradient is dictated by the number that's multiplying to x. That's it. Okay, so you got a 0 gradient. So if you've got a horizontal line, well, then the next one has to then be a vertical line. Okay, so this one's a bit different, and so I'll explain it more in the next exercise, and this is what the Year 9s need to sort of get their heads around. You guys don't need to. This is just me giving you a bit more information. Vertical line, okay, this is when you have x equals to a number. Okay, so you, for example, if I wanted a vertical line that crosses down 2, right, so at x equals 2, if I just wrote x equals 2, can you see how I've got a vertical line now that cuts down 2? If I change it to 3, so x equals 3, then it's a nice vertical line that cuts down at 3. Yeah, and if I want to cross down at 4, well, x equals 4. So for yourselves, write your notes here. If you just write x equals a, so a being a number, then you will have, so here, let's just write a so that you know. So it just means that it will have a vertical line. Okay, now That's the notes for you to take. Today, though, what are you going to be doing in exercise 9F? You're just looking to find the gradient. What is the number for the gradient? How do you do that? Okay, so I'm going to show you one formula, and then you can then do the questions. Okay, here we go. So you're going to get questions like this. It says find the gradient. So you want to find m. You want to know what m equals to. Now, I told you m is the gradient, right? What I didn't tell you is that, well, how do you calculate the gradient? Well, it is based on what they call rise over run. And it's basically how much vertical distance, so how much did you have to go up and down by, over how much you had to go horizontal by, so left and right. So in this graph here, I can see there's a point at 1, 3. I can also see that it crosses through the origin, which is at 0, 0. Now, zooming in on this graph here, if I want to know the gradient, which is this line here, I'm just going to highlight it. You're asking how much horizontal, how much distance I have to go. So from this point A to this point here, how much horizontal distance is there? Okay, how far horizontally is it? Now you can see that you're starting from 0 and you went across to 1. Well, that's only distance of 1. So horizontal distance must equal to 1. What about vertical distance? You're starting from this point and you're trying to go all the way up until this point because we always move from left to right, yeah? So moving from left to right, I need to go across 1 and then I got to go up to this point over here. So starting at this point A, and if I want to move all the way to point B, can you see I had to go 1 across, and how many units do I have to go up? So have a think. So I'm going to rub it all out. Let's count it again. So I went 1 across, okay? And then from here, I need to get up to here. So can you see that's starting at 0, and I would have to go all the way up to 3, which is that one, 3. So that's 3 units up. So then I would then say the vertical distance is 3 over horizontal distance, which is from here to here, is, or from here to here, is only 1. Okay, so it's only 1. So therefore the answer, the gradient is equal to 3 over 1. And 3 divided by 1 is actually just 3. Okay? That is how you find the gradient graphically. So if you were just to look at it graphically, right? There is a formula that you might like to use that might help you. Let's say this one. I'll give you the formula again. So m equals the gradient, and we said it's the rise over run, yeah? Now, how did I know before that this were whatever height it was? Well, all I was really looking at was I was looking at the coordinates of each one. I was looking at, well, this is the y coordinate, this is the x coordinate, right? This one has a 0, 0 coordinate, and I need to just look at 2 points. So these 2 points, how far do I have to go across from left to right? From this point to this point, I have to go horizontally 2 units. And then I have to go up by 1. True? So how did I know it was up by 1 and across by 2? Well, the logic is on the x-axis, okay, on the x-axis, if you think about it, how did I know this was 2? Well, I started off at 0, so it's over here, 0. I started off at 0, and then over here, this other x value is 2. So horizontally, I said, well, 0 to 2, what's the distance? And we know that's the difference between them. 0 and 2, well, you took 2 minus 0, 2 minus 0, you're going to get the denominator as 2. And then if you wanted to know the vertical distance, you see vertical distance, all I had to look for was I was looking at this. 1, that's the y value, right? So this is 1, so that's 1. This point here has a 1. And then over here, this is a 0. So the distance between 0 and 1, well, 0 and 1, the difference is 1 take away 0, which I'll write over here. 1 take away 0 is equal to 1, and so the gradient is equal to half. Now, if the logic was a bit hard to see, I'm gonna pick another example to illustrate my point. Let's pick maybe one from the textbook, actually. I'll pick one over here. I want one where it has 2 coordinates that are a bit separate from each other. Let's look at this one. Okay, let's look at this one. Can you see how this is a y-coordinate of 5? Yeah, the number is 5. So that means this distance here, this is 5 here. All right, so on the vertical axis, this is 5, right? And then the other one is 2. So this is 5, and that's 2, yeah? And so where is 2? Well, look at the coordinate. 2 is right here, so 2 is here. So then if I asked you, what's the distance from 2 to 5? See, 2 and 5. 2 to get to 5, well, the distance is 3. But how did I know that? All I had to do was I did 5 take away 2, and that gave me 3. Yeah, so that's a distance of 3. And then horizontally, then instead of looking at the y-coordinates, I can now look at the x-coordinates instead. Okay, so vertically, this was 3 units. Horizontally, how far do I have to go across? Well, same thing again. Let's look at the x-coordinate. This is 0. This is -2. So on the x-axis, you can see -2 is here and 0 is here. So the distance between -2 and 0, -2 to 0, is clearly 2 units. But how did I know that? Again, I can do -2, 0, take away -2, and double negatives is positive, so hence +2. But one of the things you've got to be careful is, well, what type of gradient is this? And hopefully you can tell that it's declining from left to right. It's going down. So hence it is m is equal to negative of, now it goes down by 3, and then it goes across by 2. So m equals -3 on 2. Okay, I can get a sense that sometimes this is a bit confusing for some students here. So I'm just going to give you the formula just so that you know how to do it when you get to these problems here. Here's a formula. Can you please write this down? The gradient formula is m is equal to gradient, right? It's equal to rise on run. And you can count that on a graph, but you can also use what they call y2 minus y1 over x2 minus x1. And all you're really doing there is you're finding the vertical distance versus the horizontal distance between 2 points. That's it. Now you might be saying, well, what is y2, y1, and x2, x1? It's the coordinates that you pick. So let's say this one, yeah? Let's do this one. Let's see our 2 coordinates. You got this point, -1, 1, right? And you also have this other point, which you can see it crosses through 0, 0. You got 2 points. You can call either one x1 and y1 if you want to, or you can call this x1, y1. It doesn't matter. You just need to pick one of them. So let's say that was x1, y1. Then this is x2, y2. It actually doesn't matter, right? You just need to label them. So here, what's the gradient again? Gradient is equal to y2 minus y1 divided by x2 minus x1. Using the coordinates, well, which one is my y2? y2 is this one, because I labeled it y2. It doesn't matter, yeah? You can pick whichever you want to be y2. So if that's y2, then I have 1 take away. Which one's my y1? Can you see y1's over here? So that is 0. Divided by x2, which one's my x2? Hopefully you can see x2 is over here. So that's -1 minus, which one's my x1? x1's over here. It's 0. If you put it together, you get 1 minus 0, which is 1. And then -1 minus 0 is -1. And then 1 divided by -1. You can do that on your calculator, but it equals to -1 as your gradient. Okay, so you can see here what I'm practicing, and this is probably a good time to pause the video. This is what I want you to practice. Okay, pick 2 points, like this one. You've got -2 and a 6, so that's 1 point. You've got another point, which is 0, 3. Okay, and we know that -2, 6, and 0, 3, you can label them however you want. You can call that this is the x-coordinate, this is an x-coordinate, this is a y, and this is a y. You can choose which one is x1 or y2. Doesn't matter. So this is x1, y1, for example, and this is x2, then this has to be y2, right? Let's do the gradient formula again. So m equals y2 minus y1 divided by x2 minus x1. If you follow the rule, can you see now which one's my y2? y2's over here. That's now 3. Take away. Which one's my y1? That is 6. So minus 6 divided by, Which one's my x2? x2 is clearly my 0, minus which one's my x1? That's negative 2. And you can do this on a calculator if you want. 3 take away 6 is negative 3. And 0 take away a negative 2. Double negatives is positive, so then you end up with positive 2. So the gradient is negative 3 on 2. Okay, and that way, if you follow this practice, you can then get through all of them. This one, obviously, 0 gradient. Remember the 4 types that I gave to you before. So if it's horizontal, m is 0, and then this one is undefined. Okay, so that was the 4. So when it's vertical line, it's undefined, and when it's horizontal, gradient is 0. So you can practice that rule that I just gave to you to do this question as well. You can find gradient, gradient. So if I write over here, let me do it again. Whoops, what's going on? Here we go. M equals to y2 minus y1 over x2 minus x1. Yeah? Label the coordinates. So here we go. This could be x2, y2. Remember, I'm just picking at random. It doesn't matter. This one is x1 then, and then this is y1. And then you follow the formula. So you follow the formula, and you say, well, that's y2, so that's 2. Take away y1, which is 6, divided by x2, which is 0, minus x1, which is currently 1. So you just got to be careful. As long as you're labeling them, you shouldn't make a mistake. I have seen many students make the mistake, though. So as long as you take your time, you should get your answer. So 2 take away 6 is negative 4, 0 take away 1 is negative 1, and negative 4 divided by negative 1 is positive 4. And so the gradient is 4. Okay, so that's how I want you to practice in this exercise here, is really just getting you a bit more familiar to finding the gradient of each line. So sometimes they give you the 2 coordinates. Sometimes they only give you 1, and you have to go find the other one. And clearly, it's right here. It's at 0, 0. You got your 2 coordinates, find the gradient. All right, so that's what they're practicing here. You can use rise over run, or the formula I just gave to you before, y2 minus y1 over x2 minus x1. That should help you figure out the gradient of each one of these. Can you please check the answers in the back to make sure that you're on the right track, because it's very easy to get this wrong. Okay, so I've gone now to 22 minutes of explanation. I hope that might not be an overkill, but hopefully that supports you in your learning journey. Okay, so I'm going to stop the video here. And if there are any further questions, please send me a message also, or just check the back of the answers and look at the work solutions that I've put up. Okay.